Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 3 Notes 4. So we're going to talk about dividing monomials. So if you learned about multiplying, now we're going to work on dividing. So in order to divide monomials, we have to take a look at the quotient of powers. Okay, so that's our new rule that we're learning today. And when you have a quotient of powers, you need to subtract the exponents. So what does that look like? Well, here it's kind of hard to see, but you have a to the 6th divided by a to the 3rd. So what are we going to do? We're going to subtract those exponents. So 6 minus 3 is going to give me 3. So I'm going to put 3 up here. So a to the 6 divided by a to the 3 is just a to the 3rd. You could also look at it this way. If it's a to the 6, that means that we have 6 a's on top, and we have 3 a's on the bottom. So we're going to cancel out ones that overlap because they cancel out to 1. Well, then we're left with 3 a's on the top. So that's literally writing out the property that we're using, that subtraction of exponents. So let's take a look at number 1. Well, first of all, whenever I have a letter over itself, it equals 1. So really, let's look at why that is. Why is a letter over itself 1? So let's just take a look at the a's. So we have a to the 1st over a to the 1st. Well, that's a to the 1 minus 1, which is a to the 0. Well, what is anything to the 0 power always equal? That's going to be 1. So these a's cancel out to 1. And then we're just left with 4b. So as long as you can simplify everything, remember we're going to go over our properties of simplified monomials here in a second, but we want to have the same base only written once. Same thing here. Let's take a look at these. So my 6, I'm not dividing anything by the 6, so I'm going to leave that as 6. And then I have x divided by x. Well, x divided by x is going to cancel out to 1. Now let's take a look at our y's. So we have y to the 3rd over y to the 1st. Remember, if there's no exponent, the exponent is 1. So then you're going to subtract those powers and you're left with y squared. So then we're left with 6y squared. Now notice that on both of these problems, my answer ended up without having a bottom. That means my denominator completely divided into the numerator. You always want to look where the bigger amount of exponents lie. We'll talk about that in a second. So let's take a look at number 3. When you're dividing monomials, when it comes to the coefficients, you always want to make sure that your fraction is completely reduced. So we have the fraction 5 over 10. So what divides 5 and 10? Well, 5 does. 5 divided by 5 is 1. 10 divided by 5 is 2. Next, we have x squared divided by x. So I'm focusing in on those x's. X squared divided by x to the 1st. Subtract those exponents, and you're left with x to the 1 on top. Then there's nothing to divide the y by, so that's going to stay. Well, we can write this out a little nicer. I don't need to have either of those one where. The ones are implied. So I'm just going to leave that as xy divided by 2 for my answer. Now let's take a look at number 4. So the first thing I want to do on number 4 is reduce this fraction, 4 divided by 14. So what divides 4 and 14? Well, 2 does. So we have 2 over 7. So then I have a cubed divided by a to the 4th. Now here's the trick. 3 minus 4 is a negative. We don't know how to work with negatives yet. We're going to learn about that next. So when you subtract 3 minus 4, we end up with a negative 1 or just 1. Okay, let's look at it as 1. What we want to do is we want to put our final answer where the larger number of a's is. So do you see how the larger number of a's is on the bottom? That means our a to the 1 needs to go on the bottom. Okay, then we have b to the 5th divided by b squared. Subtract those exponents. 5 minus 2 is 3, so on top we have b to the 3rd. So again, this can be written as 2 divided by 7, b to the 3rd, and then a. So that would be your final answer for number 4. Now let's review the properties of simplified monomials. Okay, so first, each base should only appear once. Okay, there are no powers of powers. You want to simplify all that down. And you want to make sure that all of your fractions are reduced. That's going to become really important on this note video. If they aren't, you will get one wrong. So let's take a look at number 5. So for number 5, we're going to simplify this down. So what I notice is that I have 5 divided by 15. Well, 5 and 15 are both divisible by 5, so I'm left with 1 over 3 as my fraction. So I just focus on it part by part. So now I've dealt with my numbers. So let's take a look at my x's. So I have x to the 3rd divided by x squared. Well, 3 minus 2 is 1. My larger number x is on top, so I'm going to put that answer on top. Now let's take a look at my y. I have y to the 4th divided by y to the first. Okay, so now we want to subtract those exponents. Y to the fourth divided by y to the first. Well, that's going to give you y to the third. Remember, if there's no exponent, the exponent is 1. Well, we can get rid of writing all those 1s. I won't count it wrong if you do, but there's no reason to have them there because the 1s are always implied. So this right there is your answer for number 5. Next, let's take a look at this one. So first thing I notice is that x squared, it's x squared over x squared. Well, since they both have the same exponent, I know they're going to cancel out. So now I'm just focusing on simplifying and reducing that fraction. 27 divided by 24. Well, 27 and 54, are both divisible by 27. And then I end up with 1/2. And since my x is canceled, 1/2 is my final answer for number 6. Let's take a look at number 7. So for number 7, what I want to do first is I want to simplify my x's. So I have x to the first times x to the third. So I'm going to start by simplifying the numerator. So on the numerator, these x to the first, and x to the third are being multiplied. So that means we're going to add their exponents to get x to the fourth. Then they're being divided by x to the fourth. Well, here I have x to the fourth over x to the fourth. So since they're the same exponent, they're going to reduce to 1. So when you divide them out, you get 1. Next, let's take a look at number 8. So now we're dividing, but we have powers of powers. So notice that this 2, we know that has an exponent of 1, but guess what? So does this 3. It's really easy to forget about that number on the bottom. Each of those have an exponent of 1. So when we take to the power of 4, we need to make sure we take and reduce, or we multiply that 4 into each of those exponents. So 2 to the 1 times 4, that's going to be to the fourth. P, now we're going to multiply 2 times 4, again, because we're taking a power of a power. 2 times 4 is going to give us 8. And then 3 to the 1 times 4 is going to be 3 to the fourth. So now we want to simplify this down. So 2 to the fourth power, that's 2 times 2 times 2 times 2. That's going to give us 16. And p to the eighth is going to stay the same. 3 to the fourth, that's 3 times 3 times 3 times 3, and that's going to give you 81. So this right here is your fully simplified form once you've distributed that in. Next, let's take a look at number 9. So again, what I want to do first, I want to simplify in the parentheses first to make my life easier. So I can simplify this x to the fifth over x to the first. So x to the fifth divided by x to the first, subtract those exponents, and you get x to the fourth. Y to the first, and that's over 6. Now remember, 5 and 1 each have an exponent of 1, and all of that is being raised to the second power. So now I need to take that 2, and I need to distribute it into every single item that follows in there. So I have 5 to the 1 times 2, so 1 times 2 is 2. X to the 4 times 2, 4 times 2 is 8. Y to the 1 times 2 is 2. Divided by 6 to the 1 times 2, which is 2. Well, 5 squared is going to give me 25, and then I have x to the eighth and y squared. That's going to be divided by 6 squared, which is 36. So this right here is your final answer for number 9. Next, let's take a look at number 10. So again, on number 10, I want to simplify inside first. So there's nothing I can do about the 2. That's going to stay on the bottom. So first, I have a to the fifth divided by a to the first. Well, you subtract those exponents, and you're left with a to the fourth on top. And then you have b to the eighth divided by b to the third. Subtract those exponents, and you have b to the fifth. So now we're taking this whole thing, and we're raising it to the third power. Now remember that 2 has an exponent of 1. So what we're going to do is we're going to take that 3 and multiply it in to each of the exponents. Okay, so let's go ahead and do that. So we have a to the 4 times 3, which is 12, b to the 5 times 3, which is 15, and 2 to the 1 times 3, which is 2 to the third. So let's go ahead and simplify that out a little bit more. So a to the 12th can't be simplified, b to the 15th can't be simplified. However, we can take 2 to the third, which is 2 times 2 times 2, and that's going to be 8. So this answer right here is your simplified answer for number 10. Last but not least, let's take a look at this one. It says write the ratio of the area of a circle and a square in a simplest form. So first of all, the area of a square is pi r squared. Well, in here, our radius is represented by t. So it's pi t squared. So to calculate the area of a square, we need to do length times width. Well, first, to get this length, okay, we take t and we go all the way across here. This length here is also 2t. So the length of this is 2t. Well, since this is a circle, if this length is 2t, then this length is also 2t. So my area is 2t times 2t. Okay, so now let's multiply that out to simplify that area a little bit. So 2 times 2 is going to give me 4. Here I have t to the first times t to the first. So we're going to add those exponents to get t squared. Now, to find the ratio, I'm going to take the area of a circle and divide it by the area of a square. So I have pi over t squared divided by 4t squared. Now I notice that I have t squared over t squared, so that's going to cancel out. And then I'm just left with pi over 4. So no matter how big your square is, no matter how big your circle is, if you put a circle inside of a square, the ratio between the two will always be pi over 4. So that's kind of a neat piece of trivia for you. So that concludes your note video today. Please make sure you take that Schoology quiz once you're done. Thanks for listening.